Hello, everybody. Welcome to the February 25th Friends of the DAO Star Party. We're really happy to have you with us tonight. And we have got a fantastic speaker and a fantastic program for you this evening. And we hope that we can give you lots of information and entertainment. And in the middle, we can throw in a little bit of astronomy there in as well. My name is Laurie Roche. I'm one of the directors of the Friends of the DAO. And online with us tonight, we have a number of our other directors here with us and a lot of other people that you will meet
Online
um,
with us
during the well that you'll meet during the time that we will be with you. We're also going to be inviting some other people along just a little bit later in the program. So I just would like to start off, of course, by acknowledging that we are, at least I am, on the lands of the Senchothan speaking people of the Ossanic territory who live and work and have been on this part of the peninsula up on the Saanich Peninsula for thousands of years, and who continue to look after this land and the sky and the sea that we are in. I would like to also thank the people who the same group who are who are for where the center of the universe is and the HAA buildings that are on there now, and that we are in continual collaboration with the people on the peninsula in order to get more work done between us in order to look at reconciliation and how we can both be working on looking after this land. We are going to be tonight doing a little bit, just a few announcements first, and then we're going to hand it over to Don Moffat, who is going to be talking a little bit about what's up in the sky these days. And sorry, Don, that there's snow up there right now. It would have been nice to have something else, but that's what it is tonight. Then we will be having Calvin Schmidt, who has been doing a little bit over the past few months, doing a little bit of extra about our virtual tour that we have of the center. And then we will get into our main speaker, Amy Archer, who's going to be speaking tonight on a topic dear to her heart from Black History Month. At the end, we're going to be having a wonderful student, Sam Felder, who's going to be in doing our Ask in Astronomy. And I hope you write down a whole bunch of different questions for him so that we keep him busy for the evening. And then at the end, we have got a great presentation by some of our friends from the Royal Astronomical Society, who, in the little times when it was really nice, was actually able to have some some clear skies in order to be able to take some of the last pictures of the comet. And we David, do we have some of the sketches that were done as well? Or I'm not sure whether or not Bill there
Yes,
is going
absolutely.
to join
It's
us. Good. Okay,
I've asked Bill to join us tonight, and
great.
yeah, it's going to be a mix of observers and imagers.
That's fantastic. Thank you. Okay, so let's just start with a few announcements. The first one, which most people are asking about and online, is, well, what are we going to do about the road? And just to let you know that we are that the road is looking really good up there. It has been totally rebuilt and is ready to go. It's paved. And right now, all we're doing is waiting for the barriers that have to go up. They have to be made specifically for this site. And as soon as they are up, then we will be able to open up the center again for public viewing and for getting things organized back on the hill. And we are hoping, cross fingers, that we are going to be up on March the 25th and March the 26th. Will be an open house up there where people will be invited to come up on the Saturday night between 5 and 10. And then on the Sunday afternoon between, say, 11 and 3, that will be open for visitors to come in and have a look around. And get into the planetarium, go up into the Plaskett telescope. We hope to be able to have some of the telescopes up for people to have a look at, and it will be kind of an informal but really fun kind of weekend for us to reopen again, and that's on March the 25th and 26th. Meanwhile, we have been really busy with the schools because we were closed and we weren't able to have our school tours as usual. Calvin, who is looking after details and technology there tonight, is Calvin and myself and another couple of people have been doing, there's Calvin, have been going into the schools and doing some programs in there right in the classrooms. And it's been just great to be able to be back in the classrooms again with the kids. And we are fully booked right through until March the 17th, which is the first day of the March break. And then after the March break is finished, we are quite booked up right through April and May. We've got a little bit left in June for schools to join us up for tours, and also for community programs to come up. So seniors programs, or any other kind of groups who would like to come up. We've still got a little bit of room for us. So we're going to be very busy once we get back open again. So unless there's any other announcements that other people have that I have forgotten, I'm going to turn this over to Don Moffat, who's going to be telling us a little bit about what's going on.
Hi, everybody. Lori, did you mention the Masonic name for the hill? It's with Texas, if I'm pronouncing it correct. Is that right?
I'm sorry, I did not. I should have done that. What Texas is it? Yeah.
Okay, okay. I wasn't sure if I was saying it right. I'm still working on it, so got it. But it's a really catchy name too, just as P calls this for Mount Doug. So very happy to use that name. So hi everybody, and welcome. And we're just going to talk a little bit about some of the things happening in the sky, focusing mostly on Venus and Jupiter a little bit later. But first, before talking about what's up in the sky, I'd like to say what's up in the gift shop. And so I'd like to send it over to Amy first and see what she has for us tonight.
All right, I will share my screen. So I'm sticking to a theme tonight as I've been getting ready for my talk, and we have these beautiful celestial bodies that are Polaris, and when you squeeze his foot, he lights up. We also have Polaris A and B, but this would be the item from the gift shop that I would recommend for tonight.
Cool. And they look like the furriest ones from what I recall.
They are, yeah.
They're the plushiest ones. So, okay, another selling point. Great. Okay, thanks, Amy. And so just to go over some basics here. So sunrise is almost earlier than 7 o'clock in the morning now. This is 7:02 a.m. today, and astronomical twilight began at 5:18 a.m. today. And tonight the sunset was at I believe 5:51, and astronomical twilight ended at 7:35. And so both sunrise and sunset have changed by about half an hour since our last star party, and that gives us about another hour of daylight already. So yay for that, although of course we love the nighttime sky too. And as always, you can check out time and date as a reliable source of information for sunrise and sunset for your location. So as I mentioned earlier, it's been a treat to watch Jupiter and Venus draw closer together as February has progressed. And you're having a bit of a sound issue. Is that right, Kelvin? Are you good?
Oh, sorry,
Okay.
that wasn't meant to to stop you there.
Okay, no problem.
Go ahead.
All right, so yeah, so we've been talking a little bit about Venus and Jupiter, and they've been coming closer together in the sky and becoming a very beautiful sight over in the western part of the sky after sunset. Mars is still well placed, but not as striking as it was in December, as it was. It's now getting further away and dimmer as a result, and we'll talk a little bit more about the factors that affect how bright a planet appears in the sky in just a minute or two. So February 19th was new moon, and February 27th, in just a couple days, is first quarter. March 7th is full moon, and March 14th is last quarter. So we've talked a little bit. Let's just put let's just put the planets up in the sky here using stellarium. Pardon me, I should have had that up. And hopefully you can see Venus and Jupiter over there. Their relative brightnesses aren't that well depicted here in stellarium, but you kind of get the idea of where they are. And you can also get an idea of the path of the ecliptic, which is the projection of the Earth's orbit in the sky, just by drawing a line between Venus and Jupiter and the moon here, the moon being relatively close to that line. So we've talked a little bit about changing in position, but what about brightness? So, for example, what makes a planet look brighter or dimmer? Well, obviously, if it has a darker surface, it's not going to reflect as much sunlight, and so it's going to look darker. And or if there's clouds over it, or say a dust storm on Mars, all of these things are going to affect how bright a planet will appear. But both Venus and Jupiter are fairly regular in those respects, in that they're perpetually cloudy. And so Venus is a terrestrial planet like the Earth, but it's enveloped by clouds that reflect quite a bit more sunlight than the Earth does. About 70% of all the sunlight that hits Venus is reflected off it. And we know that light falls off as 1 over the square of distance. So if a planet is twice as far away, the illumination on the surface is going to be only about a quarter as much. And so that's going to affect how much light then gets reflected back to our eyes. And so it's actually a combination of things: the amount of how far away the planet is from the sun, and then how far away the planet is from us, because that rule still works for the planets in terms of their distance from us. So it's a combination of things, really. And I might be able to. This is actually see if I can just flip to something else here. This is actually done for exoplanets, but it's the same idea. And this is from one of our exo exploration units that Kelvin did. So if you substitute the word sun for star here and imagine this is our sun, you get that idea. So this distance will make a difference in how much illumination there is on the surface, and then we have to take into account this other distance to us. Okay, that's all I'm talking about. And so it's really a product of those two factors. And so with Venus, there's something else to consider, and that's that Venus orbits closer to the sun than we do. So we actually see phases on Venus much as we do with our moon. And I'm just going to show a little image here that I grabbed from the Royal Astronomical Society of Canada's Observer's Handbook for this year. And what you can actually see here is a difference in the size of Venus, how big it appears, say, in a telescope at a given magnification. But also you can see that there's a difference in phase. This is nearly full, as you see over here, when it's quite small. And then when it appears quite large, it actually looks like a crescent. So it's actually, we're not seeing all of the surface illuminated as all the time with one of these planets that are in a so-called inferior position or closer to the sun. So that's going to make a difference too in terms of how much light gets reflected to us. And so Jupiter has stayed pretty much 99.9% illuminated this month, but Venus actually goes from about 91% down to about 86% illuminated. And by July, it's going to drop down to about 25% and even a little bit lower by the time it disappears out of our skies in July. So I think if you're really lucky, you'll be able to see it when it's about 18% illuminated, but it'll be close to the horizon then and actually quite large in the telescope. So, so what's actually happening with the brightnesses of Venus and Jupiter? So Venus is also going around the sun a little bit faster than the Earth. It's going at about 30, I think about 35 kilometers a second versus us at about 30 kilometers a second. So it's gradually catching up to us as it goes around the sun. And so that means it's getting closer and it's getting brighter. But the phase is changing, and so those two things kind of work against each other. And its brightness has been nearly constant this month. It's only gotten about 0.05% brighter, whereas Jupiter, because it's just getting further away and its phase is not changing, it's actually gotten about 0.1 magnitudes fainter. And so so that's kind of interesting. You'll see a bigger difference in Jupiter's brightness as a result. And there's one other factor, and that's that you're probably all familiar with, and that's how high the planet is in the sky. So if it's right overhead, we're looking through what we say is one air masses. But if we look down low, close to the horizon, when a planet's about to set, we might be looking through something like 15 or 20 air masses, and all that dust and so on in the way is going to scatter out some of the light and make things look dimmer. So that's going to affect things as well. But Venus and Jupiter, as we said, are quite close together, and so that won't affect their relative brightness this month. So look for these planets on March 1st. That's when they're going to be closest together in the sky, and I'm excited to see that. It's a nice little treat for us this month. So I think that's it for me, and I just want to put it to the RASC folks too. Did anybody see Neptune close to one of those planets this month? I can't remember. Off the top of my head, I can't remember if it was Venus or Jupiter, but there might have been a great photo op. So that'll be a question for our RASC folk who are listening. Okay, so back to Laurie and Kelvin, I think.
Thanks, Don. And I am getting an echo, Calvin. So I don't know what happens with that.
Yeah, it goes away when Dawn
I think I
mutes,
took it
so-
away. Yeah.
Okay.
Oh, okay, thank you.
Yeah.
Okay, so I'm looking forward to having a little bit of some sky on March the 1st that we can go out and have a look at that. That would be really great. So Calvin, you were going to do just a little bit more on a virtual part of the virtual tour for the Plaskett telescope for us.
That's right. Yes. We are calling it a virtual tour because that's how it began. We used our special virtual tour of the Dominion Astrophysical Observatory, and I did that, and then now I've gone into a couple more specific parts of the telescope. Last time I talked about the spectrograph. This time I'm going to talk a bit about the mount and the clock drive. So I've just got a little bit about that in 1 second. All right, that looks like it's working. Hold on a tick. Okay, sorry. All right, there we go. So the clock drive, that's this part right here. This is the clock drive that runs the telescope tracking. So this is what allows the telescope to actually stay affixed looking at the sky, even though the Earth is rotating. So we'll first talk a little bit about the mount of the telescope. So this is an equatorial mount, so that it is actually you can see this axle here is like on an angle, and that is the latitude that the observatory is at, which is I think approximately 48.5 degrees north. So there it is there. And that allows it to rotate parallel with the rotation of the Earth. So that's the So yeah, a little bit of an angle there, 48.5 degrees north. But then it also then rotates about 2 different axes. One is called the right ascension, so that goes from east to west, and then the declination goes from south to up towards north, and that way this can always rotate just using the right ascension to follow the stars as they move. And this is different from the different mounting system that's called altitude azimuth, where it kind of moves as one might think of a cannon sort of moves. It's on the horizon, and it's just rotates 2 axes left and right along the horizon, and then up and down away from the horizon, whereas this is focused more on the sky. And this is a picture of the clock drive. And this was in the Warner and Swayze shop here. So this is when they, I assume, built it, and then we're just testing it here. So this is what tracks the sky. And it works just like a grandfather clock. There's a weight that slowly lowers, and it lowers at a specific speed that this governor that is on the bottom of this picture here controls the speed of how fast that weight lowers, and then that rotates that pulls a pulley and then rotates the if I go back a bit, the right ascension axis here. It will pull on that and rotate it at the exact speed required to always follow the stars. They appear to move across the sky. Of course, it's the Earth that is doing the rotating. That way, without any or without much electricity, certainly no electronics, this was able to track the sky very accurately. Which brings us to this next point, which is, here is a photograph of some clocks. So there's 2 clocks here. One is a 24-hour clock, and one is a different clock called the sidereal time, that tracks sidereal time, which I will talk briefly about, because the Earth rotates throughout the day, and we typically say that it has been one Earth day when we see the sun at a particular height in the sky, and the next time it's at that height again, that's been one day, which is 24 hours for Earth. However, there's a problem, is that that's not the same as the stars, because as the Earth rotates on the right side of this diagram here, the Earth has also moved in its orbit around the sun slightly. So that means where the stars appear in the background, in the far out in the celestial sphere, it has been less than 24 hours for the stars. So that is one sidereal day. So one synodic day, or with the sun, is 24 hours, but the sidereal day is 23 hours and 56 minutes. So approximately 4 minutes shorter. And so that's the time that the astronomers are interested in, that they use for tracking, because of course they're looking more at the stars, not so much at the sun. So they need to keep track using a sidereal clock there. And then so the sidereal time ticks a bit faster. So that's just an interesting thing I wanted to share. That this clock, or the clock drive rather, is in the observatory, and so when I'm doing a tour, I usually point that out and talk about how this was used actually for a long time, even though this was built when the telescope was built in 1918 when it was first used. I think this was used all the way up till like around the 1990s. So it got a lot of use as this analog way of tracking the sky, compared to what I believe the more modern way to do it is to use electronics and very, very precise electric motors. So that's about all I have to say for that. And I believe
And Calvin, we have the
Yes.
clock drive the clock drive itself is the old one is
Yeah.
down in the bottom of on the first floor.
Yes.
That's right.
Yes, and
So
also
and-
the clocks are in
and
the
the-
center of the universe.
That's right.
that's right.
Yeah, thanks, Ben. So we've got those on display as well, which is really cool. And I believe it's Marilyn that occasionally goes in there and winds them to actually have them go because they still work. But I remember her saying that she would pretty much have to go like every other day or something to wind them. So it's like too much work to always have them going.
Special occasions.
Yeah.
We'd have to have a special key to get to do that as
Right. All right. So Lori, I believe you're up
sorry.
next.
I'm
Yeah, there we go.
the next time that you are up to the center and you get a chance to have a look, please go in and have a look at the clocks in the gallery, and when you're in the main building, then you'll be able to actually see the clock drive. Dan Posey, when you're giving a presentation in the dome, do you have like a special light that people can kind of see into that so they can get a look at the clocks or the drive?
No, but we all carry around our cell phones now, which means that we have a
Yeah.
handy flashlight when we need it.
Yeah.
Because many of the internal components for the clock drive, particularly the big brass governors, have been taken out over time just to avoid them being vandalized or destroyed. There's a little bit less to look at in the clock drive itself. You can still see some of the internal workings, but it's not a complete assembly anymore, unfortunately.
We have to
Okay.
we have to point it out. It's on the ground floor by about quarter of the way round from the front door, and it's a bit dingy nowadays.
But
we
it
do-
has some good
yeah.
explanation of how it works attached, which is always helpful to read.
Right. Do you know when those pictures were taken, Calvin or Dan? Because
I did look at the labels. I think they have descriptions for all of those images in our archive. But I didn't see any years. But obviously, well, the one in the Warner and Swayze shop must be 19
Probably 1916.
Probably
Okay,
1916.
so, yeah.
Okay.
And
Because all the
given
mechanical parts were done by the fall.
given how clean the dome looks, it's probably fairly soon after the telescope opened or such. And I didn't notice, but is there a spectrograph hanging off the back of the telescope?
Yes.
Well, then that would be after 1918 then.
Okay, thanks.
Floor looks like it was a little higher up then, judging by where the pier is in the picture. Did you get some mozzarella?
I'm going to switch over now to Amy's. We're going to get started with Amy's presentation, and I'm wondering if Ben, you can you're going to be our person who can introduce Amy for us.
Yes, it's my pleasure to do just that. Amy was supposed to give me a few more details of her life, so I promise not to make too much stuff up now. Amy is our vice president and unofficial chief operations officer, which means that she helps keep Friends of the DEO going. Amy was born in Edmonton of roots from the West Indies, from Trinidad and Tobago, and has spent most of her life over here on the West Coast. Actually, we're technically on the West Coast, right? She appeared to us about 7 or 8 years ago at a International Astronomy Day down at the museum with her daughter in tow, who was inquisitive and interested in science. So Amy, as a mom, came down to meet the astronomers, and she has steadily got more and more involved with our activities and now our operations. Amy loves this community and loves the astronomy community as well as the community in Victoria, and hopes to make the world a bit of a better place for her daughter and the rest of the world. She works by day for the health authority, has a part-time business making soap, and I don't know where she gets all the time to work with the Friends of the DAO, but I'm very glad that she does. So without further ado, here she is.
Thank you, Ben. I'm going to do a fancy screen sharing, so just one moment. Sorry. Ooh, not that. Okay. Oh, sorry, I'm just going to breathe first. So, hi. So, as Ben said, my name is Amy Archer. I am the daughter of Russell and Anne, and I am mother to Alyssa. I am a first-generation Canadian. My parents came from Trinidad and Tobago in the West Indies. I am presenting to you from the territory of the Songhees and Esquimalt nations. And we're quite excited around my house right now because it's just started snowing in town, which doesn't often happen. So we're pretty excited tonight. For my own and for the FDAO, it would be lovely if people could just type in their chat boxes where they're joining us from. We always love to know where people are tuning in from, so that would be great. So the theme of Black History Month this year is Ours to Tell. This theme represents both an opportunity to engage in open dialogue and a commitment to learning more about the stories Black communities in Canada have to tell about their histories, successes, sacrifices, and triumphs. With this theme in mind, I am going to be talking to you about the intersection between the night sky and the Underground Railroad, and sharing some stories from the people in that time. If you have questions as I go along, please type them into Zoom or into the YouTube chat box. I will answer your questions at the end, so don't worry, I'm not ignoring you. I will get to them. I feel like I need to start this with a bit of a trigger warning. I am going to be talking about slavery, and I am going to be talking a little bit about racism as well. So I'm just so people are aware. So the easiest way to start, so we're kind of all on the same page, is to set the stage for what was going on 200 years ago. So, starting in 1793, Upper Canada passed the Act to limit slavery. Understand that slavery was still legal and socially acceptable in Upper Canada. This act did nothing to free any of the enslaved people that were in Upper Canada. What it did was establish that freedom seekers, when they would become free when they arrived in Upper Canada. In a bit of a contrast, in that very same year, the United States passed the first of two fugitive slave acts. The one that had passed in 1793 allowed the local government to apprehend and extradite escaped enslaved people from within the borders of free states and send them back to their point of origin. This law also brought down punishment on anyone who was caught helping an escapee. In 1834, August 1st of 1834, The Slavery Abolition Act was passed throughout the British Empire. In 1846, the boundary between the United States and British Canada was established at the 49th parallel, and this was with the Treaty of Oregon. This treaty also established where we are on Vancouver Island that we would remain part of British Canada. In 1850, in the United States, the second of the Fugitive Slave Acts was passed, bringing harsher penalties. It established a system of commissioners that promoted favoritism towards owners. This led to the recapture of many formerly escaped people. And I think this has been kind of made popular through some films in the last number of years as well. So people are probably familiar with this. Then in 1857, the Dred Scott decision was passed in the United States courts. So the decision said that no Black person, free or enslaved, could claim US citizenship. So understand that if you were not a citizen, then while you could own property and run a business, as long as you paid the taxes, you could not vote. You could not testify in court against whites. If you were robbed or assaulted by a white person, you had no recourse through the court system. Public institutions or services for Black people were segregated or completely non-existent. Then in 1858, just to bring it home for those of you who are on the West Coast here, in 1858, there was the arrival of between 600 and 800 Black pioneers from San Francisco at the invitation of Sir James Douglas. This invitation and these folks coming north helped cement Victoria as British territory. And this migration of pioneers brought people that I have spoken about before, but that you might be familiar with, such as Mifflin Gibbs, Sylvia Stark, and Charles and Nancy Alexander, as well as obviously many others. In 1860, the transatlantic slave trade came to an end with the arrival of the Clotilda, which was the last ship that I'm aware of that arrived on US soil after that was already supposed to have stopped, which would take us then to 1865, when finally the 13th Amendment was passed by the United States Congress, which abolished slavery in the United States. So astronomer Dr. Moya McTeer said, one of the most heartbreaking things about slavery in the US was the people being forced apart. She said that she imagines there must have been some small comfort in knowing that wherever they were at least seeing the same stars. Okay, the Underground Railroad. What is it? So, the Underground Railroad was a network of people and places that would assist escaping enslaved people find their way to freedom. Facts. The Underground Railroad was neither underground, nor was it a railroad. Just so we're all clear on what we're talking about. By the 1800s, the Underground Railroad was well established. It would have taken many generations to establish. Though the term Underground Railroad, from what I could find, was first used to describe this network in 1831. It is thought that around 100,000 people traveled the Underground Railroad. 30,000 of those people made it to Canada. When people made it to the border, that 49th parallel, the common entry points were a suspension bridge that was over the Niagara River, or across the Detroit River to Windsor or Amherstburg. For when they were crossing the Detroit River, people would cross by boat. Some people tried to swim across the very fast-moving current. Or in the winter, some people would try to cross on foot when the river froze. People would make it this far, and then the water, they wouldn't make it across the border, right? Like, things happen. So that's, yeah. The peak of the Underground Railroad was between 1840 and 1860. The thought is that between 1850 and 1860 alone, 15 to 20,000 people crossed to Canada. So what I discovered through my research was that many of the enslaved freedom seekers would have to get to the other side of the Ohio River, the other side of the Mason-Dixon line, where they would be met by a conductor to help them on their journey. This would be quite the distance. So if you're thinking of, like, from Vancouver, it could be the distance of getting all the way to Calgary or further. And you're navigating this on foot with essentially people chasing you. Nowhere is safe. Some conductors did travel into the southern states to get people and bring them north. But like I said, some people had to make it that far before they could go the rest of the way with a conductor. Travelers on the Underground Railroad would ideally escape on a Friday night. The reason why Friday night is because that left until Monday until an ad could be posted of the escape. So that gave them the weekend to try to make some distance. One thing about the Underground Railroad was the necessity to travel at nighttime, for the obvious reason of having the ability to remain inconspicuous. Though nighttime brought its own set of issues with it, of course, right? There were sundown laws that were in effect at these times. So sundown laws were laws that indicate that no Black person should be in public in the town after sundown. These, of course, have evolved into sundown towns, and there are still sundown towns that exist today. I think the stars must have been, such a comfort to so many people as they started their journeys north or south, because that's what they had. It was nighttime, and the one constant would be that night sky. But this brings up another question, which is celestial navigation. So when you start to research about celestial navigation, you will find that there are often these tools that are involved, right? You need these tools. They help you find and follow the stars and to confirm that you're on the right heading. So let's imagine having none of these tools at all, plus being in immediate peril if you're caught. So if you're traveling north, you have Polaris that can help guide you. Though if you're traveling south, they would have had the Southern Cross, which is would have been a wayfinder, but not as easy likely to have spotted as Polaris, which is the North Star. Coming from a history of oral tradition, many of the travelers on the Underground Railroad may have heard stories about navigating by observing the stars and other night sky patterns that had been passed down through generations. Notably, West Africa has a long and deep connection to the night sky. African people have been observing the stars and planets since ancient times. For centuries, Africans have searched the skies for meaning, order, and understanding. Not so different from European culture. With sites such as Nabta Playa, astronomy is still practiced in Africa. Culturally embedded astronomical knowledge and observation were used to inform social ideologies and behaviors in society. One of a number of telescopes on the continent today, of course, is SALT, which is the Southern African Large Telescope, and it's 11 meters in diameter. Calvin, how big is our telescope? What are we in meters?
The size of the mirror is 1.8 meters of the Plascat telescope.
So the Southern African telescope is just a little bit bigger than ours. So these stories and history, no doubt, helps the travelers on their journey. For enslaved people that did not get to learn how to read or write, remember this would have been illegal, reading the night sky would have provided important clues for survival. Again, escapees most certainly got turned around and lost in the dark and would have been captured. Not everyone made it to the Ohio River. As history tells it, the North Star played a key role in helping enslaved people find their way north. Escaping people could find it by locating Ursa Major, also known as the Big Dipper, a well-recognized asterism, which is quite visible in the night sky, especially in the late winter and in the spring. As the name implies, its shape resembles a dipping ladle. The Big Dipper is made up of 7 bright stars in the shape of a ladle with a curved handle. The North Star, or Polaris, is the first and one of the brightest stars to appear in the night sky. It is the only star in the constellation that does not move across the sky or change. Sorry. It always points to the north. A common misconception is that the North Star is the brightest star in the night sky. It is actually only around the 50th brightest. Polaris is easily identified by first finding the Big Dipper or the drinking gourd. Away from that handle is the side of the bowl that forms the pouring edge. The 2 stars making up the Big Dipper's pouring edge point to the North Star. So people fleeing to the south would likely have been able to follow the crux or the Southern Cross. And I'm going to be really honest with you, I don't know a lot about the constellations in the Southern Hemisphere. So I am, for this evening, I'm focusing on Polaris, and I'm focusing on the people who came to the north. I plan to one day head down to the Southern Hemisphere so that I can learn a little bit more about that. But maybe I've seen this from Trinidad at some point, but I have no recollection of the Southern Hemisphere. So escaping people would follow Polaris to guide them north toward the free state of Illinois, Indiana, and Ohio, or on to Canada. On clear nights, the North Star can easily be seen, though on cloudy nights or when running through forests, swamps, or bayous, fleeing people would need to rely on tree moss to guide them. Moss grows on the cooler north side of tree trunks, as well as following the North Star. Escaping people relied on the network of the Underground Railroad, of course, to help them arrive safely. It is not a coincidence that Frederick Douglass named his newspaper the North Star. Gloria Rall wrote, "Escaping slaves faced overwhelming obstacles. They had to travel alone and at night over strange terrain. They and their families were almost exclusively concerned with survival. So sky watching wasn't an activity to be engaged in for its own sake. The astronomy important to them was learned for its practical value. And even that was so dangerous that they concealed their awareness of the night sky. As a result, unlike other cultures, African American songs or stories on celestial topics tend to be scarce. Okay, so let's try it. Here's a picture of the night sky. This picture contains both Ursa Minor and Polaris. So here's the question, here's the quiz. Can you find Polaris in this image? And for me, I know that there are astronomers on this call that are like, yeah, Amy, it's right there. It's obvious. But for me, this is what I see. And I'm like, they all look the same. So I'll give you a second to take a look and see if you can find the North Star there. All right. Just wait, it's not moving forward. There it is. Were you able to spot it? Did you find it? So we can go back again. And it's hard. Like, I would just, I mean, for me, and this is probably one of the things that that I am getting better at the more that I am around the center, but I see the stars and it's hard sometimes to just pick out that one. So I can only imagine trying to pick out this one star. So the asterism, again, that's part of is Ursa Minor. And so here's the full with Ursa Minor in it. And big thank you to David Lee, who you guys will see a bit later in the star party, who took these images for me. So
Amy, I want to admit that I cheated. I had to use the plate solver to show these things in.
All right, so the Leonids. So the Leonids are a prolific meteor shower, and they're associated with the comet Tempel-Tuttle, which they're also known for the spectacular meteor storms that occur every 33 years or so. Peaking in November, they can be among the most awe-inspiring, naturally occurring events in space that can be viewed from Earth with the naked eye. So again, they intensify every 33 years in conjunction with the Tempel-Tuttle comet getting the close orbit to Earth and the sun. The resulting dust particles create this barrage of meteors. They're called the Leonids because they appear to emerge from the constellation Leo. So in November of 1833, there was a Leonid storm, unlike just about any other in recorded history. Over the span of approximately 9 hours between November 12th and 13th, it was estimated that as many as 240,000 meteors fell. At its peak, as many as 50 to 100,000 were falling per hour. That's kind of what was thought to have been running across the night sky. With it being completely visible across the entirety of North U out here on the West Coast. So the 1833 Leonid meteor shower created terror, I think is the best way to put it. And it made many people believe that the world was coming to an end. So many people didn't understand that the meteors were simply crossing the sky and burning up in the atmosphere. Rather, what they feared was happening was that they were crashing down and exploding in various points across the world. In essence, this was creating an apocalyptic disaster. So just right. So the thought is that you're seeing these things come down and you're like, well, just because I'm not seeing them, catch fire right here, they're doing it somewhere else. The world is coming to an end. So one Alabama farmer was reported to have been awoken by all the commotion from in his undergarments. He shouted, "The world is now actually coming to an end, for the stars are falling." He then vowed to never drink another drop of alcohol if he survived the night. They say that there's no record of whether or not he kept his promise. Amanda Young was a young enslaved girl in Tennessee in 1833. She actually passed away in 1920. So she awoke in the midst of the storm, unaware of what was going on, but wide-eyed at the reaction of the slave owners. The memory of what transpired that night stayed with her for the rest of her life. Her great-great-granddaughter, Angela Walton Raji, reported her ancestors' words, which has been maintained in their family as oral tradition. So what she said was basically big stars were coming down really close to the ground, and just before they hit the ground, they would burn up. We were all scared. Some of the folks were screaming and some were praying. We all made so much noise. The white folks came out to see what was happening. They looked up and they got scared too. But then the white folks started calling all the slaves together. And for no reason, they started telling some of the slaves who their mothers and fathers were, and who they'd been sold to and where they were. The old folks were so glad to hear where their people went. They made sure we all knew what happened. You see, they thought that it was Judgment Day. And yes, many of the slave owners were so terrified that Judgment Day was here that they started making spur-of-the-moment apologies and reparations to those they held in bondage. Though imagine for those people who were escaping, who were kind of in the midst of the Underground Railroad at that time, night turning into day would have been terrifying. Not because of a fear of Judgment Day, but because there would have been nowhere to hide. And a fear they would not know. Again, the science just wasn't where it is now. They would not have known how long this extended period of time would have lasted for, and there would have been nowhere that they could have gone to hide. This is usually, the nighttime is usually when they're able to travel. So I'm going to tell you another story that involves the Leonids. But I'm going to tell you about Josiah Henson, who was born enslaved in Maryland. He escaped to Upper Canada in 1830. He was a minister and a conductor on the Underground Railroad. He likely helped approximately 200 enslaved people find freedom. A story that was recorded in Josiah Henson's autobiography is this that I'm about to tell you. So he says, "I remained at home working on my farm until the next autumn, soon after which time I had promised to assist in the restoring to liberty the friends of James Lightfoot, the individual who had excited my sympathy at the meeting at Fort Erie. In pursuance of this promise, I again started on my long journey into Kentucky. On my way, that strange occurrence happened, called the Great Meteoric Shower. The heavens seemed broken up into streaks of light and falling stars. And found the village aroused, and the bells ringing, and the people exclaiming, 'The day of judgment is come.' I thought it was probably so, but felt that I was in the right business, and walked on through the village, leaving the terrified people behind. The stars continued to fall till the light of the sun appeared." I love that story because he's right. Like, if this is Judgment Day, what a better profession to have than saving people. He's going to do all right, so he could just keep on going. So the last time that like in the 33-year span for the Leonids that they peaked was in 2022. It was the night of the 17th to the 18th of November. And I remember it very well because I was so excited, and it was very rainy, as it always is on the West Coast here. So there wasn't even a glimpse that I had. So I'll have to wait till 2055, and hopefully it will be pretty remarkable. So I want to thank you for listening to me this evening. I have to say, I feel like I have barely brushed the surface on this topic of the intersection between the night sky and the Underground Railroad. And I am super engaged in this now, so I'm going to be doing more research. So hopefully this won't be the last time you hear from me on this one. I have to say, though, first, when I take a moment to look up at the sky, and I understand that I am I'm a little bit privileged because I have access to this amazing telescope, and I spend time in dark sky probably more frequently when I'm on the hill than a lot of people get to. So I get to stare at those beautiful constellations often. I know there's so much to learn and discover still, but just for a moment, I am always so grateful and in awe of the sky, and of course of these people who use the stars to assist in finding their freedom, a freedom that paved the way for me to be talking to you today. Thank you. And do you have any questions?
Thank you so much, Amy. Oh my goodness.
So questions can be put in the chat boxes. I have not been watching them, though. Thank you, David. So David's just saying that he enjoyed the stories.
That would be great. I had a question that I don't know whether you can answer or not. In 1865, when the 13th Amendment went through,
Yeah.
who was the president of the United States?
I know
Oh,
this
dear.
question. My mind is not there right now, Lori.
Okay. I just wondered, who.
Wasn't it Lincoln? Wasn't it Lincoln? I don't want to say that out loud. Ben?
It was not Lincoln.
It was not Lincoln.
He was earlier, wasn't he?
When it was passed by Congress,
Yeah.
it was Lincoln, but it wasn't ratified till December after
That's right.
Abraham Lincoln was killed. So
I don't know who came after
Johnson.
him. Sorry.
Or 1865. Yes, it was Lincoln in
Ben.
1865. Yes.
Yeah, he was president when it was passed, but not when it was ratified.
Yeah, not when it was ratified. So because it took
He was
a while. Yeah.
deceased.
Amy, can you go back to that picture with all the different pathways?
Mhm.
That
Yes, I can. Just a second. I have to do it the same way again. Right.
I just have to.
And it was Andrew Johnson. I have been.
Andrew Johnson. Okay.
I passed the quiz.
Yes.
Doesn't count, Ben.
Yeah.
Are you able to get that
Okay,
picture
so the
up?
pathways.
There we go. Yes,
Yeah.
the pathways that were.
So
that
all
were
the different
there.
directions, you mean?
Yes, yeah, with all the green arrows. That
Sorry, this one takes.
okay. Because what I was, yeah. Was okay. That's the one I was looking for. Sorry.
Sorry, I was clicking like crazy. That's
Yeah.
But yes.
Okay. So if I could get that picture back up again.
Coming. Sorry.
It's coming. Okay, sorry. It's just taking some time.
Hmm.
Oh, we seem to have lost it, did we?
I see the star field.
Yes, we're just looking at a star field.
Yeah, sorry. Praying.
I think she's also frozen a little bit as well. So what I was interested in when I was looking at that picture, if I can remember correctly, was that it seemed that there was one the from Texas, the Texas area, is that they kind of slipped around and went kind of back around and went down. I mean, did they head back into Mexican territory?
Yes.
Or did they just stay within, the Texan, like in Texas? And was that more of a safe haven back then or not?
No,
Here we are.
Texas was, of course, the last state to like Juneteenth, right? Is because that's when the 13th Amendment was kind of I would say ratified in Texas, like when that news was brought to Texas. So no, they would have gone through to Mexico or come, yeah, exactly. So the southern route, or if they went through Florida, it might have been to try to get to the islands to get out. But that whole patch there was not friendly.
Right. That whole area. I just wanted to let you know that my mother's family is from Amherstburg, Ontario. And so she grew up very much knowing the background history and of the slave of the Underground Railway going through. Mind you, she also grew up in a time when Black people were also in different houses, and they were the maids and the people that helped out back in there. We're talking about the 1930s, and she had some friends at her school that were Black, from from previous families that had been there. So that was interesting. I'd kind of forgotten that Amherstburg was kind of part of that whole issue.
Yeah.
All right. Does anybody have any other questions that they would like to ask of?
Yeah, Amy, I see that there's an arrow
Oh,
that goes
okay.
through Maine into New Brunswick.
Yes.
Yes.
So that was interesting. I didn't realize that that was a route that people followed.
Yeah, kind of however to get out. And there's a trail as well that's now been made into a national trail that would take from Niagara area all the way through to New Brunswick. Don has a question.
Hi everybody. I just joined in, but good to see you all. But yeah, that main trail that goes from down south up into New Brunswick builds the Acadian population that now lives in New Brunswick. So my mother's Acadian, she's from New Brunswick, so that northern peninsula in New Brunswick has its roots from people that were down mostly in Louisiana and then all the way up the East Coast, that kind of traversed up into Canada. So yeah, really rich history from this as well. Yeah,
very interesting.
So there's a question from Dawn wondering about Iowa, why it was avoided. I don't know. That's the I know some, my United States geography is pretty good on the coast, but not so great in the middle there. And I don't know why that would have been skipped over. I'm not sure about the politics of the state at the time. It could have had something to do with that as well.
I think Bill answered in the chat very well. Iowa is flat corn country, hard to stay hidden when there's no, it is just not a very good landscape when you're trying to move and not be seen.
Amy. Oh,
yes.
sorry.
So I was
Was
just
this-
going to get Janine, do you want to um, put yourself off and ask Amy a question?
Sure. Yeah. Thanks so much, Amy. I wrote a comment earlier and I wanted to clarify it a bit, is that I just find astronomy is such an incentive to look at things that one might not otherwise look at. And I'm speaking for myself. I've known a bit about the Underground Railroad, but never to the extent that I was drawn to learn from you. So good combination. My question now is, how did you go about researching this obviously hard to find something about topic, and where do you plan to look further?
So Google is my friend. Obviously, lots on Google, lots of questions. So I'm fortunate to have some great friends across this country who have a lot of knowledge about Black history, and so they were a resource to me. I was able to actually watch a couple dissertations even that people have done. Because these things are now all online. So my hope is, of course, I plan to go to Windsor and kind of look in that area and just look around and see. I've spent quite a bit of time on the East Coast, so I'm familiar with some of those states and the night sky on the East Coast of the United States a little bit, but I would like to just spend more time there for sure, and learning more, attending and going to some of the Underground Railroad museums and talking to some of the experts. That's
Amy,
yeah.
Where we used to live in Maryland, there was a small African American history museum, and I imagine it's not the only one, and they're run by volunteers who probably would be only too pleased to share stories, because that was round in that part of the world, which is between Washington and Baltimore. There were disused buildings that were connected with slavery. There were the plantations were further south, but I imagine there's some rich pickings there for you.
Yes. No. Exactly. Okay.
Hey, Amy,
Can I stop? Can I do that, Calvin? Does that mess things up?
you can stop if you want.
Yeah.
I had a question, bit of a question about the timeline. I think you showed a timeline at the beginning.
Yeah.
And it said something about how I can't remember what the proper policy term was, but it's like Canada removed the ability to own slaves in Canada, and then is that what sparked the Underground Railroad?
No, the Underground Railroad already kind of, it was already it already existed prior to 1793. Like it was already something that was happening. Keep in mind at that time in Canada, we had Upper and Lower Canada. There was a lot of areas that we now think of as Canada, including where we are, that weren't. So people coming north would not have been, unheard of. Yeah.
Okay.
Does that make sense?
And so the escaping the Underground Railroad took people from the south and then just brought them north, where it was just easier to get away from being enslaved.
I think it was even more than that, right? Because upon arrival, you were considered to be free. So that would stop, because
okay, kind of
it was
fresh
possible
slate
for the I guess the police, like the people who would come to chase and bring people back, like the bounty hunters, for all intents and purposes, would sometimes cross into Canada to bring people back. So you can't do that anymore. Like that, those sorts of things kind of stop that. And I'm sure that there are cases where it still happened, but then that's it's illegal. So yeah.
Well, thank you so much. Yeah.
So Janine has an interesting comment in the chat saying astronomy is such an amazing in quotes, to too many other fields. So related to this, I've been interested in and now pursuing in some detail the connection of the Plaskets to the Danish West Indies, where they were involved with owning plantations and managing plantations, owning slaves. So yeah, so John Stanley Plasket's great grandfather Wilfred and his brothers and some of their older children set voyage to the Danish West Indies in 1810. Wilfred died on the way, but the remaining Plaskets landed there and slowly worked their way into the society, owning land and owning slaves. So as I researched this, I've now found a bunch of access to newspapers for that period of 1810 to 1850, when 1848 is when slavery was ended in Danish West Indies. And it's the newspapers. It's such a interesting insight into how it kind of worked, and the conditions and the contrast, between the slaves and the owners. They were like numbered 10 to 1 or something, but there's ads for plays and to piano tuners and everything. Well, the people that owned the slaves, owned the plantations, had amazing houses, resources, and the slaves, meanwhile, we can imagine what conditions they lived under. Also discovered that there was a great trade from Halifax down to the West Indies, providing fish of various sorts. And then I'm reading a book on the plantation life in the Danish West Indies again, which is a very interesting, really illuminating the society. But it's all very fascinating. Very sad part of history. So yeah. We all can learn from it.
Yes. Yes.
So this, by the way, anybody named Plaskett that comes from the U.S. Virgin Islands is related to our John Stanley Plaskett, basically. They got their name from the family, one way or another.
Like that lady in Congress, right?
Yes, Stacey Plaskett is related to John Stanley Plaskett, as far as I can tell.
Don, you were mentioning something there about Sir James Douglas, that he did have African heritage, but I think, if I'm reading some of the things correctly, is that they tried to downplay that as much as possible at the time, so that he would that people didn't know about it for quite a long time.
So yeah, Sir James Douglas was his father was Scottish, and his mother was noted as being a free Black woman from the islands, from the West Indies. Yeah, and the thought is that when the letter was written to the Black population in San Francisco, inviting them up, that it wasn't really he wasn't doing it as a camaraderie sort of thing, but I do believe, and what I have read is people believe that it definitely played into the decision to do that, right? That it would be okay, and that he was a very clever man, it would seem, Sir James Douglas. So yeah. So I don't know that it was advertised, but he took slack for it as well. He did. He was questioned on things that maybe other people wouldn't be questioned on because of his heritage. So yeah, it's interesting, to think, though, that in 1850s, 1840s, the Hudson's Bay Company was trusting, he was being very trusted to make major decisions. He decided to move the fort to Victoria from Vancouver and things like that. So yeah.
Okay, are there any other questions that anybody has? I think we've tried to pull in the ones from Zoom. I don't see the ones from YouTube, so I'm not really sure.
And I would just say, like Leslie has reminded us on YouTube, that that of course, when you're out east, when you're in southern Ontario, there are Sandwich there, Amherstburg, and Windsor, Niagara as well. There's lots of places and churches and things to go to. There's some amazing new monuments, and I'm aware of some great new paintings, murals that have been done, really depicting this time in Canada's history. So
I guess I'm going to have to go down and visit my relatives. Yeah, there we go. Have to try that.
But just one
Okay.
last thought, the
Yes, go ahead,
image of people escaping to freedom in Canada reminded me of The Handmaid's Tale on TV. You know, that's they were escaping whatever, I forget, I've been so long ago that I watched it, but they were escaping to Canada to freedom from the bizarre air situation in the US.
Well, we won't talk about the group of people that might want to come up here anyway.
Yeah.
All right. I'm going to move it over to Sam Fielder right now. Sam has hi Sam. Thank you for joining us tonight as our Ask an Astronomer program when we are up at the center and over International Astronomy Days and everything. We've always had people who have put themselves out there to answer any questions. And of course, a really good answer is I don't know, which is kind of part of the whole deal. Sam is right now kind of working on his master's of science and at UVic, and is with if I can just Helen Kirk, who's with at the HIA, and Sam is working with some radio telescopes right now, and doing some of his work on starless cores. And I'm thinking, I don't know anything about starless cores. So maybe if other people don't have other questions, that would be my very first question to him is, Sam, within some place that you're going to talk about this where I might be able to understand, you want to get into some of that. But thank you, Sam, for taking some time tonight. We've got about 15 minutes or so, or more or less, depending on what's going on, for people to answer any questions. So put them in the chat, or just put your hand up if you want to on Zoom, or if people are looking on YouTube, can answer any questions about astronomy that you may have. Okay,
Yeah,
Sam.
thanks for
start off with those
having me.
scores. There you go.
Yeah, perhaps I'll dive right into your question, Lori. What are starless cores, and why are they important for star formation? So, of course, when you think about looking up at the night sky, all we see is, for the most part, just the blinking lights that are the stars that are nearest to us, right? But of course, there's many other objects out there, such as galaxies and nebula and all these things. And what I study primarily is the start of that whole cycle. So, of course, gas that's out in these star forming regions, they'll end up collapsing down and coming together, and depending on the conditions of that gas as it comes down, we get the stage of those stars known as starless cores. So there's these higher density areas, these little clumps of material, that, depending on their properties, can go on to the next stage of their lives, known as the protostellar stage. So this is the kind of starting to be a star, and then once it doesn't, the conditions are right, it can go on to be a fully fledged star that then turns hydrogen into helium and goes through its life. So I work in a very narrow window of the whole life cycle, just when those gas clouds are collapsing down. So yeah, very interesting science there.
And how many of them would go on to be stars, and how many of them wouldn't?
This is a great question. It depends on the environment. So environmental factors do a great job at telling us if something will collapse down or not. There's many factors, such as the temperature. If the temperature is too high, that means the dust is moving too fast, right? It has too much thermal energy, and it'll actually end up dispersing itself back out and not form stars. So it needs to be cool enough gas, which is a little bit counterintuitive, right? You think, stars are hot, right? They burn. So shouldn't the gas that forms those stars be hot? But it ends up that you actually need cool gas to come down enough so that it starts up that star formation processes. So yeah, there's not many starless cores that are studied in detail because they're a relatively short time span of object compared to, stellar lifetimes. So we can only resolve so much right now. And so this is quite a new field that we're probing into, these very, very kind of diffuse cores. So yeah, right now we don't have enough statistics to say how many go in, but we do have some characterization of all the physics that are there. So yeah, it's an ongoing question.
And it has to be done with radio telescopes because it's cooler and farther, like.
Yes and no. The main reason why we use radio data for this, so radio data is of course just another form of light, right? When we look, let's say with Hubble, we work in the optical, so what we would see with our own naked eyes. Of course, James Webb moves into the infrared portion of the spectrum, but all the way down the end of the list is the radio waves. And the reason why we use radio for star formation is star formation primarily happens within these very dusty regions of the galaxy. So when you look up in the night sky, if you're in a super, super dark zone, you can see the kind of hazy band of the Milky Way. And of course, the Milky Way disk, that flat structure, is where all those high star-forming regions are. And in the optical, if you take a picture of it, it looks very dark, right? It's very opaque in those wavelengths of light. So to see through that opaqueness, you need to move to lower and lower frequencies or higher and higher wavelengths all the way down in the radio. So it's just a consequence of where those processes are happening. So we need to use radio in order to pass right through those clouds and to get to the stars that are inside of them. So, yeah.
Sam, it's Janine here from Nanaimo. I've got a carbonaceous chondrite meteorite, which was formed for the early part of our solar system. But also, I'm wondering, is study of meteorites inform any of your field?
Not so much. No, meteorites are, yeah, they're not studied too much in astronomy, other than when you're looking at the composition of things that are coming from outside of the Earth. The composition of these meteorites can infer a lot about the processes that form those elements, where those elements come from. Because in the end, everything that we know that's higher than hydrogen or helium comes from star processes that fuse those elements into higher elements. And then, of course, those stars go supernova and disperse all of that back out. So it makes some information with respect to what the stellar processes are that made those meteors. But for my research specifically, that really doesn't come into play. Yeah, meteorite science is a whole nother thing on its own. So, yeah.
Well, the reason I was asking is for the Allende meteorite. I understand that recent science has been able to identify nanodiamonds that came from the supernova explosion that fed the gas and dust that created this. So that's where I was coming from. But thanks for your clarification.
Yeah, absolutely. That's on the other end of the star's life cycle, near the end of their lives. I work at the beginning. So yeah, very different physics that happen. And the physics of supernova are not very well understood. So it's a big, big, big topic right now in astronomy. That's for sure. Yeah.
Calvin, did you have something you were going to ask?
Oh, right. I think you implicitly answered my question because I was curious if you were doing more the observational side of looking at images and trying to just see things, or were you doing like simulations of these collapses?
It's a good question. Yeah, everybody that's in the field of astronomy usually gets kind of split into two groups. There's the theory group or the simulation space, and then of course on the other side is the observers, the things that we work with real data. Yeah, for the most part, I sit on the observers end. So the data that I'm working with comes from the Orion molecular cloud complex. So if you picture Orion in the night sky, of course, there's Orion's belt in the middle, there's the two stars above and the two bright stars below. If you picture that on the night sky, the molecular cloud complex that my data set comes from is in the would be the northwestern part of that constellation, as it kind of borders the galactic plane that comes in there. So my dusty regions that I have some observational data comes from that part of the sky. So yes, I am an observer for the most part. I do use some simulation data to infer about the processes that, what should I be seeing given what we know about the current star formation processes. But other than that kind of connection, I mostly work with physical data. Yeah.
Great, thanks.
Yeah, the university is primarily, at least for the people that work with galaxies, is very simulation based, because that's as computing power is getting cheaper and cheaper, we can make a lot of simulations at really high resolution. So that's a big portion of astronomy right now. But yeah, the other big side is, of course, observing real data. So that's where I'm at. Yeah.
Which radio telescope are you using, or a number?
Ooh, yeah, absolutely. So telescope is maybe not the correct word that I would use. It is an interferometer. So it uses many different antennas. And the interferometer that I use specifically is the ALMA interferometer. So it's based in Chile, in the northern part of Chile, up on the mountaintop, very high up. To get rid of a lot of the atmospheric noise. It's a very dry, which is good for radio data. The water in the air tends to play a big part of the noise that comes in on those radio waves. So yes, the data that I work with is from the ALMA interferometer. So yeah, there's about 50 or so antennas up on that plateau that are configurable, and they drive all the way from right next to each other all the way out to about 2 kilometers distance apart from each other. So yeah, very high technical facility that they have there. So really good data. Yeah.
Jim Hesser, are you still on with us? Jim was one of the first people to work on the on ALMA, or did an awful lot of work on ALMA. So I just wasn't sure whether he was still on with us or not.
Yes, I am, Lori.
Oh, there you are. Okay. Any hints for Sam?
I think he's incredibly fortunate to be able to work with Alma.
Yes, absolutely. Yes. And specifically, I work with, so there's different configurations and different wavelengths that are probed with this facility, and they're split up into a number of bands. I think there's all the way from band 3 currently all the way to band 9. And for each one of those bands, there's very specific, and this is something I don't know much about, so take this with a grain of salt, but each one of those bands needs specific equipment built for them to be able to process those signals at those wavelengths. And the HIA, or the NRC compound up at the top of Observatory Hill, was the main contributor for the band 3 data that's being put out by ALMA. So they built all the physical pieces of equipment to get that band 3 data. So and that's the band that I use for my data. So yeah, it's fun to work on data that all the people that supervise me helped to build. So yeah, it's really fun.
Wonderful.
Hey, we've got a question from Randy Ankin over on YouTube. They ask, what proportion of astronomy grad students started as amateur astronomers?
Ooh, great question. I would say, in terms of, so in our physics and astronomy department at the University of Victoria, I think we have about 50 to 60 students that are directly in astronomy. that aren't in the general physics or the medical physics field. And I believe I would say it's a minority currently. Of course, most of us have scientific backgrounds where we've enjoyed science as children and kind of grew up doing that. But in terms of amateur astronomy, I think it's quite low, unfortunately. I'm in that group. My dad does a lot of astrophotography, and I used to live in Edmonton, where there's some really good display of northern lights for most of the year. So yeah, I was lucky enough to grow up with basic stuff like that. But most students, I don't think, are amateur astronomers in that regard before coming into the science field. So,
And
yeah.
based
So we've
on
got work to do.
Exactly.
Based
Yeah.
on my experience as well in undergrad, though, I think it's about similar, where it wasn't too common to meet people that were there were some that already had telescopes and did photography and stuff. I think a lot of people went into undergrad in astronomy. I was not a photography person. I wasn't a constellations guy. I didn't know very many constellations, even though I was very interested in astronomy. But I think while after that undergrad thing, I started to have an interest for the stuff. Although I don't quite go out every night with much at all. But yeah.
Yeah,
It's kind of interesting, the divide of professional astronomers and amateur astronomers.
Yeah.
Different people.
I'm old enough that I started out as an amateur astrologer.
Astrology.
That's really old.
Okay, Dennis. Well, looking at your background there, I think you might be, you haven't really changed very much there at all. So
I'm not sure how to take that, but anyways.
Dan, what were you saying there as that you still don't know very much about the constellations? You, one of our best astrophotographers?
I confess I rely on the computers to do it all for me.
All right, we're gonna have to get you out from underneath the Plaskett from the Plaskett room, get you out into the main thing. Is there anybody else that has a question for Sam tonight? Got some, we could keep on going, of course, about galaxy systems and sun systems and all kinds of things like that. We could do that for hours.
Actually, I do have a quick question, Laurie, for
Sure.
Sam. Hey, Sam, I haven't seen you for a while, not since the summer.
Yes, for sure.
So we know you deal with massive amounts of data. Does it take you a long time to do this?
Yes. So what's very, very neat about these facilities with interferometry is that there's so much data there, but all that data is taken in a relatively short amount of time. Especially with these newer facilities, you don't need a lot of time looking at your object in the sky to get a good picture. However, even for that short amount of data, my data sets is already in the terabytes of space. So it definitely takes a long time to get through that data and to reduce it down enough to get to the imaging process. But more and more in astronomy now, we have resources in place and cloud computing platforms and big data archive facilities that can handle that data. So yes, good thing I don't need to have anything local to me. It's all on the cloud, and I use cloud resources all the time. It's not something that you wanna download anywhere, because even the downloading is gonna take days, right? So yeah, lots of data being processed, but the systems that are in place are pretty powerful. So yeah.
So in terms of the data collection, do you look at the same area all the time, like at a certain cadence, or are you just going wide and going surveying back and forth over areas you've never seen?
It's a great question. So a lot of telescopes will do survey programs where they pick a patch of the sky and they'll take the data over a wide region. However, some of these facilities are better suited for pointed observation. So you know the specific area of the sky that you want to look at. And so you put in a proposal saying, I have these specific regions that I want, and then the telescope will then point to it and collect the data just for that specific point in the sky. So for instance, the data set that I work with, I have 73 of these proposed starless cores in this Orion molecular cloud. So the proposal that was submitted is these 73 little circles on the night sky. And then with those little circles, you have the amount of time that you would need to get the picture that you want. So in terms of the observations that were taken, I think the on-source time is what we call it, was around 4 minutes or so per little circle on the sky, and there's 73 of those. To put that into comparison, the telescopes or the interferometers that were in the previous generation would have needed around 8 to 10 hours of on-source time for the same.
So these are a lot faster, I guess.
These are a lot faster. Yes, they're still minutes, but minutes is nothing compared to half a day or so of data collecting. So minutes is fantastic. And in terms of the cadence, it's whenever anything can get scheduled in for your observation. So my observations were taken over the course of 6 months. So there were 7 different opportunities or schedule blocks. So they went through. All the telescopes then point at the same region of sky. They take data for, about an hour or so over all the fields, and then they move on to somebody else's data. And they repeat that process 6 or 7 times, or as much data as I requested. And then all that data is then given to you in a big lump sum after all the data has been taken. So yeah, in terms of the amount of on-source time, it's minutes. For the total amount of science, it's going to be in the low hours. So yeah, relatively quick.
Thanks a lot, Sam. That's it. You've really kind of told us a little bit about how that whole process works, and we're always really happy about that. And we'd love you to come back sometime to do a whole. Sorry, I'm sorry, I was muted there. I just wanted to ask you back sometime for the summertime when you can really give a little bit of a talk and give us some information about what you're finding in this large database. That would be great.
Absolutely. Yeah, I guess one of the things that I want to leave everybody with is that these interferometers don't take pictures of the night sky. It's not like traditional telescopes where they point in a region and then you get a pretty picture, right? All of these radio signals are just waves. They're huge waves, and all those come down, and those are just signals. And so there are a bunch of zeros and ones that are in your computer. They're not in image form. You need to take that data and produce the images from that data. So
so Sam, what does your visualization look like then?
What do you mean by visualization?
Well, you're taking all this data. Traditional stuff, we would see an image of something that kind of looks like what we'd expect. Do yours look like that, or your graphs, or what do you produce out of it?
Interesting. So what interferometers produce when you image the data is basically a representation of the sky brightness.
Okay.
So it's basically how bright was that region of sky that you were looking at. So it's basically just like a picture, except you need to go from the raw data into the picture form. So there's that extra step, which can take quite a long time. For me, it's taken almost 8 months or so to get all of my images processed. That's because I'm in the big learning phase of my degree. But if you can get it really done really quickly, that step doesn't take too much time. And you can go from the raw data to the images rather quickly. And then once you have the images, of course, then you can do all your analysis on them. So yeah.
Yeah. So Sam, you have the outline for your talk now.
Exactly. Yes. Yeah, I plan on giving one in the summer here. So yeah.
Excellent. Thank you.
That's great. Sure. Thank you so much. All right. Sam, thank you for coming. And if you would like to stick around for a little while, we've got some things on comets. I know they're a little far away from starless cores, but we'll kind of go from there. I'm going to drop it over to David Lee and to Brock Johnson, and to who else is there? Dan Posey and Bill Weir. And I think maybe Dan or David, do you want to take it off first?
Yeah,
And
yeah,
look
I'll
around?
start it off, and
Sure.
I just wanted to let everybody know that tonight it's not a purely kind of an imaging presentation. I invited Bill Weir, who is probably one of our foremost visual observers, and I'd like this to be a friendly, not a friendly battle, but just a friendly conversation about what happened with our observation of this comet. And I'd like to say, you know, like I first heard about the comet probably like mid-January. I think maybe around January 19th, you started seeing these kind of articles showing about the green comet, right? And a lot of us got really interested, but the weather wasn't the best. But still, it was an opportunity. And of course, Bill on our distribution is all often either encouraging or goading us into looking for these objects. So I know Bill has these remarkable eyes because I can't always see what he sees. So I mean, I did take the challenge. I just went out with my binoculars. I had a hard time actually seeing this comet. But before we get started in that respect, I just want to talk about this green comet. And I promised David Payne that I would mention this because he had done some research into why this comet is green. So I think through our conversations, we realized that we had, I mean, a lot of us have seen a lot of comets, and sometimes they're green, sometimes they're not. So he did mention to me, and I said, yeah, that'd be a great fact to talk about tonight. So apparently the sunlight kind of splits the coma. There are these things called diatomic carbon molecules. They get kind of split up into single carbon atoms, and that's what produces the green color. And anybody who was part of that conversation, chime in if I got it wrong, but I think that's basically it. I think we were all talking about what are these diatomic. Anyways, that's why we think they're green. So I'm just going to switch over to my screen, and Brock, if you don't mind, maybe having on hand the Rasa Folio collection, just in case I need to refer you back, because I've got these generally or grossly sorted into January and February, but I don't have the order within the month. So we may have to do a little digging. A lot of the information is actually on Zenfolio in the text part. So if you don't mind pulling that up, that would be great. Okay, so I'm just going to switch over to the first month, and I'll talk about my first viewing of it and other people's first viewing of it. Okay, so I took the challenge on January 19th, and I took out my should have taken out my telescope actually, but I wasn't sure whether I'd be able to see this or not, and I thought, well, why don't I start with my lowest common denominator, which is my eyes and my binos. I totally gave up on my eyes, so I rushed to the binos, and I still had a really hard time. So what does David do when he can't see anything? He takes his camera out, right? So I pointed the camera into the general direction. And at that point, if you can see with this photograph, you can see the dipper in this kind of configuration where these pointer stars, as Amy was talking about, actually point down to, I think Polaris is slightly out of view. There's Kochab, which is part of the Little Dipper. But if sighting it, what I basically did, I went, found the cup to the dipper, and it went straight down. And I had a wide enough field lens that I wasn't going to miss it. Even I wasn't going to miss it. So I kind of shot in that general direction, and I did see this guy right here. He was just kind of underneath the tail here, and that's just kind of a bit of a blow up. Not much detail, but at least I can say I kind of saw it, right? I saw it through my camera. So then I think we started getting images in, and actually maybe a photo first. Bill, can you tell us about this?
Oh, that was well down the road in my observing it. My first night was January 11th.
Okay, I wonder if we should go to
when it was really tiny.
Should we go to the collection maybe?
I don't know.
Yeah, here's the collection here. Do you see your, these aren't in order, unfortunately, so
It'll be
maybe you
really,
can,
is that the whole collection?
this is the whole
One
collection, yeah.
Right at the beginning was January 11th. If you scroll down to the bottom,
Go to the bottom, I see a tiny one.
yeah,
This one
that's
here?
it. Yep.
Okay, excellent. January 11th,
Yeah.
there you go. That even precedes my attempt. Yeah, go ahead.
Yeah,
Maybe
'cause
tell us your
I've
first.
seen that one. I went down to Taylor Beach, down below my house on the water in the Chosin. And I think that's the night that I ran into two women that came out there too.
Oh.
But they were there just to lay down in the middle of the road and look up at the sky and look at the stars, which was
Okay.
very funny. But yeah, because I first heard about this comet probably about 6-7 months ago when it was first spotted and predicted that it would get to be very bright. I don't know how those people predict those things, but there
Yeah,
were
so
rumors.
this is before the news got a hold of it, right?
Oh, the news got a hold of it once people started posting on social media
Yeah.
pictures of the green, and that's why it became so famous, sort of, because nobody, well, social media, right? They see something and, oh, look, it's green.
Yeah,
And I mean, most comets are green.
exactly.
They just haven't got the publicists that they do now.
Yeah, they needed better marketing for the previous comments.
Yeah, because I have some
Yeah.
really old film shots of comets taken horribly, like I said, on film, that show a green core in comets. But
Okay,
there was
yeah, go
only
ahead.
once. There was only once that I looked at it that I had this image in my brain that I was actually seeing a tiny green glow. And that was on because these early ones, the moon was up. And so it was looking smaller too.
So
But
maybe not much green with the eyes then.
no, you hear people saying that, but I think that there's this illusion with the various shades of gray and our eyes and our brain that we see colors when they don't really exist.
Yeah,
because
I think
gray
you're right.
on black gives an illusion to our brain that it's green if there's not enough brightness to it. But it's been fun. When I see these things, I get kind of this, I want to see it as many times to watch it change. And so that's why Friday night, this last Friday, was my first fail of when I went out. And
So
I think,
you basically go to extinction then.
yeah, and I think it still would have been visible, but the moon was up, and and then the sky was starting to get cloudy a bit, and well, hazy. And at that moment, people came into the room right next to where I was and turned on all the lights, and then it got hazier. And so I think I lost my little window of opportunity.
Oh, well.
There was a beautiful moon
Yeah,
halo, though.
Yeah, you never know when it's going to be the last time, do you? Really?
Yeah.
Okay, so maybe if I work backwards through this collection, it might be the right order actually. So here's my image. So that's the night I tried. That's the 19th, and this one's the 19th. This is the same night, right?
But no, it would have been on the 18th because mine are always in universal time.
Oh, okay.
And so really they would be on the evening before.
Okay.
The dates.
So the other thing that I remember about this comet, at least in the photographs, is this kind of weird fan shape tone to it. Obviously the green as well in some photographs, but really this fan shape, which was kind of cool. We're going to see all sorts of other detail as well as we go through these images. Oops, wrong way. So it's the 21st, getting a little bit later. So were you seeing a more definitive tail as you were going on in the time?
Yeah, it got bigger and wider.
Okay.
Because I always, except for the first couple of nights, but then I switched to I always used the same telescope, but I always tried to use the same magnification so that the changes would be noticeable. and for consistent, almost like doing science.
Dare we do that? I don't know.
Well, for
okay.
consistency.
Okay. Oh yeah, there's his 22nd. And here's a photograph coming up. Now, this is Lucky Buds. He's not here tonight, but quite a nice nice image here, actually. Very interesting. This kind of spire effect. You see that many times. Last time we talked about that.
That's an ion tail.
Yeah. And here's the coma area here.
And then in front you can see what's called an antitail.
This one here.
I think that's due to orientation. Because it was on a steep incline in and out to closest to Earth.
Yeah, I know a lot of the imagers were having trouble getting the green. It kind of just depended, whether they saw it or not, or able to display it or not in the image itself. Yeah, this is further down, closer to the end of the month. This one is this is Lucky's as well. 30th, okay, closing on the month. Now, were you seeing even more detail in the tail?
Now, on all of mine, it's the same field of view, so you can see how much bigger it is.
Oh, okay, that's a good comment.
That's why I try to use the same eyepieces, so that you can tell if it's changed.
So you're not zooming in; it's the same field of things.
Yes, it's the same bigger, right? 1 degree field of view.
Okay, that's interesting. This one is Ron Fisher's from Up Island. Yeah, again, you'll see this kind of almost like fan shape, and then the spire at the back. Nice green. Another one from Lucky. Now later on, you're going to see this comment next to kind of famous objects. So that's coming up as well. This is Dave Payne's. That's kind of pretty. He mentioned this galaxy up here too when he shot it. Now this one was interesting, just as a technical note. I think he was actually tracking the comet's head. Now normally when we photograph, we're just tracking at sidereal speed, meaning we're tracking the stars, right? So if there are other objects that are moving at a different speed, they become smeared. Or if we focus on them, then the background becomes smeared.
Yep.
So David, this picture is being taken as it's going away from us, right?
I'm not sure where it is oriented. Do you know, Bill, at this point?
What's the date?
It's the beginning of February.
It's the 2nd? That's actually right at the moment of closest. That's when it starts swinging back out again.
Okay.
Because I can't figure out whether I'm looking through the whole tail, through the tail and it's going away from me, or which direction it's going in. Like, can
I think you can
help?
see a hint of the ion tail there at the bottom, and the ion tail goes away from the sun. It's carried out in the solar wind.
Yeah, I mean,
Okay.
when you see the tail, the sun's here, right? And then it always shoots away from the sun, right?
Yep.
If you play with the contrast, I guess you can easily see that ion tail. Is that right?
Yep, you probably could, yeah.
Okay, cool.
Many of these you could probably enhance even further to make some features more apparent.
Cool.
And here's another one. This is another one of Ron's near the end. This is back to the end of the month.
I really like this one because this is sort of what it looks like visually.
So closer to your field of view then, probably.
No, but
Is that what
more
you're
of
saying, Bill?
like, because it's black and white,
Right.
Oh, right.
and
We don't see color, right?
and we don't see how long the tail was. Like, I'm not discrediting his photo, but it's a shorter image. So it doesn't show the full extension that the tail could be. So
Right.
it's because we can't visually see way out.
Yeah,
Because the tail on that was like several degrees long.
Yeah,
But
you can see
doesn't
you
it
can see
doesn't
that
go
in,
out of my field of view
yeah, you can see
in
that
a
in
1 degree.
yeah, you can see
Yeah.
that in Lucky Bud's pictures, right?
Yeah.
Okay, we're back to you, Bill.
Yeah.
It's the beginning of the month. And then this one is
It's Dave
Dave
again.
Payne's again. Yeah.
So
Yeah,
see
you
what
really-
you're visually seeing, just that bright little fan, and how it's lopsided too.
Yeah. Yeah, it's kind of a I don't know, like a ballpoint pen point shape, I guess. That's Ron's again. And back to you, Bill. Beginning of February.
But see, there was a lot of moon then. You couldn't see as much.
Yeah, we're getting close to the recognizable juxtapositions.
Bill, you make it look like there was so much time to get out there and see this one. It certainly didn't feel like that as the month was going on, but it's like every second day there's another chance to get out there.
Well, it's an illusion, Dan.
I need 15 minutes. You guys need hours.
Yeah, rub it in.
Yeah, I just need 15 minutes. And by this time, it was in my backyard. So I could just put the telescope outside and then keep looking out and then just run out and could get what I needed.
Can you briefly describe how you sketch these? Like, are you looking through the eyepiece and sketching at the same time?
Okay, so these are reproductions. The stars are all, so this one was very low power because I was trying to get it with Mars.
Yeah, you see the tree line too, right?
That's a tree, a really tall tree. So I go out with the same field, like I just take an eyepiece, a 2-inch eyepiece, and draw a circle around. And then I put all the dots in of stars that I can see. And I do the core of the comet. And then we'll do scratchy line sketches of where the fan should go and how far and how intense. And then later I'll bring it in and I'll put all the dots in exactly the same spot. And then I use mostly like a smudge stick, like it's a piece of round up, looks like a little cigar of paper. And that I put the pencil on and make it so that I can just kind of try and reproduce the subtlety.
Yeah, it allows you to
see.
Yeah, it allows you to produce that gradient from the bright nucleus to the fantail, right?
So I have all my original sketches that will exist in a book with the reproductions so that they could be compared to show that it just was made to look more blurry. Because, it's harder with red light to really do the fine,
right?
the soft touch.
Yeah, it's interesting how you work. I mean, I assume that's actually what you did, though sometimes I imagine you being far more heroic. But when I thought about it, I thought you probably just anchor spots and then do the finishing stuff later, right?
They're pretty much the same, except you can't do that. Like you have a mechanical pencil, so I can put so it's like a scribble in to make the fan shape or whatever. But it pretty much matches. It's just
is that like a shorthand, right? Like a shorthand for you, right?
It looks exactly the same. It's just it hasn't been blurred.
Okay, so we're going to start seeing some recognizable objects. So this one is, I think this is Alex. There's Mars, and there's the comet. On the very, very same night, I photographed this. So you can see the shape. I was never really good at getting the green on these wide fields, but what I did find interesting, and I know that Sid commented on this, was the dark areas, and they really are there. At first, I thought, I may have done a morphological transformation, and for people that don't know what that is, sometimes a star field is actually very rich, maybe overly rich, and if you're trying to show only the brighter portions of it, you can actually erode the dimmer and fainter stars. So I went back and looked at this, and I thought, oh yeah, maybe that's what happened here. But I went back to my primary image, and I didn't do any kind of erosion of the fainter stars, and these were still here. And Bill, I think you confirmed that visually you believe that these are there, right?
There's dark nebula in that area.
Yeah.
You can see it on wide fields of Orion, the constellation, or
it's quite...
of Taurus.
Yeah, very cool. And there we go, Fib 11. And there is that Mars right there?
The orangey bit's Mars, yes.
Yeah, there you go. So a couple of viewpoints of Comet and Mars. And let's see, there's another view. Now this one's interesting. Tell me about this one, Bill.
Okay, I was out at Pearson College, and I had my really big telescope. So it actually looked like this. It had like a shell to it. There was like, it had that hood at the front. It was more streaked, like you see in the images, but that's because I was using a 20-inch telescope and relatively low power for a 20-inch telescope. So the field of view is very small, but it was very cool. It was like stunning.
I wonder if that could be a kind of a bow shock. I don't know if comets would have something like that.
No, I heard.
Yeah, they do.
Now, correct me if I'm wrong. I remember reading in the news that the head broke up or it fractured. Does anybody remember the comet that it had fractured?
No, there was one imager who thought he saw that, but then it was like on Twitter or whatever, and he kept believing that he'd spotted it.
Oh.
He's a person who likes to make his name on social media as a imager, and it was bad tracking.
Oh, okay.
Or something like that, because everybody else kept showing him images saying, no, it's not real.
That's embarrassing.
And then he looked at his data and thought, oh yeah, it is. It's just the camera was moving. Or
that's okay. We get overly excited sometimes, and
because
maybe we're wrong, right?
There are comets that break up.
That's what comets do to us, right?
There are comets that break up.
Yeah, there's another one from Lucky. I think Mars? This is Mars. Yeah, I think it is
Mars. So Lucky was shooting that at the same time. We were both shooting from his yard for the next shot.
Oh, very cool.
And you will notice the same lack of stars.
Right.
The field is smaller, but you'll see those same lacks, especially to the left of the image.
And it will become very clear on the next one.
Dan, were you guys shooting from his backyard, or?
Yeah, we were shooting in Gonzales, so not bad conditions. He's not too far from the water, so there's not too much light, but we're still under the light dome, and the Hyades and the comet weren't far enough from the zenith that we weren't getting quite heavily polluted.
He's using an SCT, right? Like an X-Star?
This one was, I think this was his 8-inch with a Hyperstar.
Oh, okay. So he's sucking in a lot of light.
Yeah.
All right. So this is a good segue for you, Dan. Tell us about it.
So this was fortuitous because, unlike Bill, I was not able to get away from work and be quite so motivated for the last month. So it was only lucky prompting me to get off the couch on Friday evening, I think it was Feb 10th or something like that, that had me going out. And we didn't go too far, so we shot this from downtown Victoria, but I prioritized going for the entire feel rather than the comet. So in order to keep all of the background features in focus, like I've tried to do here, the comet had to drift a little bit, which also meant that I had to cap my exposure time quite briefly. So this was, I think, just over an hour, which isn't terribly long from a light polluted site to be going for a shot. It has the Hyades star cluster on the left, Mars, and then the comet right by the head. And then some of those darker patches that you probably noticed in a few of the other images have been pulled out with enough detail to have true structure in this, as well as some of the other dust clouds in the Taurus molecular cloud. So this is just the benefit of having a small, fast, wide camera lens that's able to do everything all at once. And it was just really lucky framing to be able to get everything in all at the same time and fit it in the field of view.
Dan, that's amazing.
That's really nice.
Amazing.
Yeah, that particular lens has been a great tool for you, hasn't it?
I just consider it a cheat code for astrophotography. I don't know that there's anything else that's allowed me to do more with less time. And I find that as the working world always has demands, and other hobbies other than astrophotography have demands, it's really nice to have in the bag for a night like this, because I don't have anything else that came close. I did have another rig going, and an hour from that location wasn't enough time at f5.6. I couldn't do it.
Yeah, nothing beats aperture.
Yep.
All right. So here's some more kind of wide field things. This is with Alec Lee. So I actually remember being with the beginners group down at Cattle Point and seeing this view in the south. So Orion very prominently in the south, and then these other areas visible fairly high up, actually, quite high up.
But I think this also shows that, it's not this magnificent green long-tailed comet that's sitting in the sky. It's this little wee thing that was up there, and that some of the gorgeous shots aren't the realistic ones of what people look at when they just simply look up in the sky. This
So
would be more
I take it visually it was disappointing for you.
For me,
yes.
I was able to see it very, 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 not very much at all. But I'm just saying, I think that it's the difference between being able to really get all the sketches and get the gorgeous astrophotography, and then have it like, this is really what you would see if you looked up just with your eyes. This is what it would be more like. Dan, are you going to say no to me with that?
No, I was going to actually say that, like, for me, it was striking how faint it was, because that picture goes quite deep, and the comet was difficult to pull out with any kind of real structure, albeit we were past closest approach, we were past it being at its brightest. I wasn't shooting from a pristine location or anything like that, but it was hard to see. I couldn't find it visually.
Yeah. I have to say it. I wouldn't say it was lackluster. I mean, it has some beautiful structure, but I don't think it was as bright as anticipated. I mean, it's just, I mean, even when you looked at the magnitudes, it is a diffuse object, so you can't really go by the numbers, so to speak. But yeah, it was still fun chasing it. But it's no Hale-Bopp, that's for sure.
David, we have about 1 more minute.
Okay, we're actually wrapping now. So this is with it beside Aldebaran. This is my shot with it near Aldebaran. There's a comet and the Hyades here, which is kind of cool. And this is our last shot. Brock, tell us about this.
Well, it was on the 14th, and I had wasted another previous opportunity, and I wasn't going to let it slip by. So I managed to get set up and get a shot. Didn't have much time on it though, so I learned a lot. I probably would have done it differently if I had another chance, but
Well, that
things
we
go
all
on.
we all say that, right?
Yeah, I did see it with binoculars a week or so before, and it was actually pretty clear. I took Bill's advice at one point and picked up these monster binoculars from Canadian Tire. They're not really great, but they're huge, so they were able to actually pick it up pretty well. So
Yeah, I don't feel so bad with my 8x42s.
It was very
Anyways.
cool to see it with the star cluster.
It was.
Yeah.
Oh yeah, 1647 or NGC.
Yeah.
Yeah, that was cool. Anyways, that's all we have.
Cool.
Our short journey visit with Comet.
Well, thank you very much, David and Dan and Brock and Bill, and then bringing in some of the other people from the RASC here in Victoria that has got out there in the cold and actually took some of these pictures. So there we are. Thank you everybody for coming along with us tonight. We have come a long way from starless cores to gorgeous comets here tonight, and we've come a long way from our historical background from the 1700s right up to things that were just taken a couple of months ago or a couple of weeks ago. So that's amazing. Thank you everybody for being part of our group here tonight. Thanks to Ben Ben kind of in the background there a little bit, to Calvin doing all the work, to Amy for giving us a great presentation. So like that. And we had other people that were online that were helping out as well tonight. So we really, really appreciate all that. Please put March the 25th and March the 26th in your calendar as being when we are hoping to be back up on the hill, and everybody can join us up there. It's been a long time. It's been since back in September that we were on the hill, and we're really looking forward to getting back. So if you've got any questions or anything, just fire them into info@centeroftheuniverse.org, and we'll see what we can get going. Thank you so much, everybody, and have a good night. Be safe out there on those roads, and make sure you put on your hat and mittens. Okay.
Good
Bye,
night.
everybody.
Good
Good
night, everyone.
night.
Thank you.